so law of cosines, again, is going to be applied as a way for us to find. There were 3 different formulas for it. That's not true. There's really only one. The reason I give you 3 is because it just depends on what we're solving for to start. Okay, so this equation, that little a, this is a excuse me, if we're solving for a side length, we'll let that be a. And then we're going to always take cosine of the angle opposite. So when we're using the law of cosines, we'll either be solving for this side length A or for this angle A. Okay, the other B and C, those are going to be the remaining 2 side lengths in the triangle, and those will be provided. It does not matter. Interchange the B's and C's, it all works out the exact same. So that's why we don't need to memorize 3 different types of these formulas. It's literally just one. Tomorrow you're going to have an assignment where I'm going to give you all just descriptions of triangles, and your task is going to be to find the missing angles and find the missing side lengths. It's not going to say use law of cosines here and then use law of sines there. You're going to have to decide which one to use. So I'll kind of touch on that as we go through this and explain my thought process when we see the triangles.
Is there specific triangles for law of cosines and specific triangles for the other one? Or doesn't
No, it's all the same types of triangles.
It always works the same.
Just sometimes we'll have to use law of sines, sometimes we'll have to use law of cosines to find the missing angles and side lengths. And in fact, we're going to have to do the law of sines in this first example anyways, okay? So, our first triangle, we have an angle A of 60 degrees, a side length of B of 20, and a side length C of 30. So I'm just going to draw that generic triangle, labeling the corners or vertices as uppercase A, B, and C, and the opposite sides, lowercase letters of A, B, and C. And then based on this, the description, we have the 60-degree angle at angle A. We have B to be 20 and C to be 30. So typically, after I draw this triangle, and that's a lot of you on Monday weren't drawing the triangles. You were just like, yeah, I see the pattern. I can do law of sines and find the missing things. Draw the triangles, okay, especially tomorrow when that assignment there's no like clear-cut way of how to start. Draw the triangle because it's going to tell you what do we have to do first. And typically, I want to start with the law of sines, but for that to happen, I need to know an angle and the side length opposite. We don't have that in here. So the law of sines is not possible at this moment. And that's why we need the law of cosines. Okay, so we're going to work to find this side length A, and that's what's going to give us this ratio to then allow us to use the law of sines to find the other missing angles. So since I'm solving for a side length, that's going to be this A squared. It doesn't matter what B and C is, so I could write this as 30 squared plus 20 squared, and then minus 2 times 30 times 20. And then cosine of the angle, which is 60 degrees.
So it doesn't matter like the order of how you set it up?
Nope, because with addition, order doesn't matter, right? 2 plus 3 is the same thing as 3 plus 2. Same thing with multiplication. Order doesn't matter. From here, it's basically just calculator work. You absolutely could just plug this in all in one go and take the square root of that. That'd be short, but that's a lot to type in. So I'm going to actually do a couple things leading up to that, and then ultimately come up with this value of A in a second. So I'm going to first figure out 30 squared. It's 900. 20 squared is 400. 2 times 30 is 60 times 20. I think that's 1,200. Let's check that one. So minus 1,200 cosine of 60. Then I'm going to add 900 and 400 to get 1,300. And at this point, a lot of you are going to be tempted to go 1,300 minus 1,200, right? That feels easy. Right? It's right in front of us, right? The 1,300 minus 1,200, and we want to call that 100. However, this 1,200 is being multiplied to cosine of 60. So we cannot add it to this 1,300, as tempting as it is. Okay, we can't add these. In fact, this is as much as I'm going to do, and now I'm going to go ahead and just take the square root of this whole thing and let the calculator basically complete it from here. So I'm going to square root everything and let a equal the square root of the 1,300 minus 1,200. So second square root, 1,300 minus 1,200, cosine of 60. I should also double check to make sure that I am in degree mode, which I am. If we're not in degree mode, we'd get something completely wrong. And this ends up being 26.45. We are rounding side lengths to the nearest tenth. So that's 26.5. And there are no units, so we'll just leave it as 26.5. Yeah. Yeah. Yeah, you could have done everything and like square root all this, plug that in one go. Yep, absolutely. Okay, well now we have this side length and the angle opposite, allowing us to do the law of sines. So I'm going to take the side length of 26.5 divided by sine of 60, and it equals, well, what do we want to find next? Let's find angle. It doesn't matter, we're finding one of the missing angles. Let's go with angle C. So 30 divided by sine of C. And then this is exactly the work that we were doing yesterday. So I'm going to cross multiply. Get 26.5 sine of C equals 30 sine of 60. And then to get sine of C by itself, I'm going to divide by 26.5. And then C is equal to the inverse sine of that 30 sine of 60 divided by 26.5. Yeah, Drew?
Since the side length A isn't exact, does that mean that when you do that math, it's not tight?
Yeah. So this is rounded. What's nice is the angles are going to be rounded to the nearest degree, so us rounding here shouldn't make much of a difference. Math Excel is really picky about it, and that's one place where you'll kind of struggle with that. So the better thing to do to keep things exact for as long as possible is, instead of this being 26.5, let it be the square root of 1,300 minus 1,200 cosine of 60. Okay, I'm not going to do that in here, but that's how we would keep this exact for as long as possible. Okay, that's a great point to bring up. Okay, so then taking the inverse sine of 30 sine of 60 divided by 26.5, but again, if we were leaving it exact, instead of 26.5, I'd put this whole square root in the denominator. But I'm just going to go with the 26.5 to keep it a little more simple. And that ends up giving me 78.6 degrees. Rounding that up gives me an angle of 79 degrees. So if angle C is 79, I can find angle B by using the fact that all angles add up to 180. So 180 minus 79 plus 60 is 41 degrees. All right. So we, like I said, we actually end up using the law of sines anyways. We couldn't at the start because we didn't have that angle and side opposite. Okay. I'm going to go through one more problem, and then I'm going to have you all work through one, and then that'll be it in terms of what we're doing for the notes today. Get you going on Math Excel shortly after. Yeah. Yeah. Okay, so based on this description, it looks like we just have 3 side lengths and no angles. I'm still going to draw the triangle. A, B, and C. And the side lengths, A is 6, B is 9, and C is 4. So obviously we can't use the law of sines because there's no angles, right? If we want to use the law of sines, we need that angle and side length opposite. So without us having any angles, we don't have that opposite pair combination, which means we need to find an angle to start. Now, we actually have to find a specific angle before, we can't just pick whichever one, okay? It has to be the largest angle first. So let's make a note of that. This is a really important piece of this. So need to find the angle that is opposite of the longest side first. Okay, and that's so important. Now, if you don't do that, a lot of times will work out just fine, but there might be times that you run into an issue and you're going to end up getting an angle that is not correct. The reason being is it all relates to, because when I'm finding an angle with the law of cosines, we're going to take the inverse cosine. And so remember, with inverse cosine, the restricted domain is between 0 and 180 degrees. So when I take the inverse cosine, I can get any angle between 0 and 180, and thus I can get an obtuse angle if it is going to happen, but we're going to be able to make sure that we catch that in the right place. If instead we didn't find the obtuse angle using the inverse cosine, and instead we were hoping to catch it with the inverse sine, the problem with that is that the restricted domain for inverse sine is -90 to +90. So if we needed an obtuse angle and we tried to take the inverse sine of that, we're not going to get it. The largest angle we're going to get with inverse sine is +90. So if we find this largest angle first, we'll make sure that we catch that obtuse angle right from the start. This part you don't need to know. That's just me explaining why it's important that we find this angle, the biggest angle first. Okay, so just something we have to commit to know. So the longest side here is B, 9, so we're going to find angle B to start. Since I'm finding angle B, I'm going to set the whole equation equal to that side length opposite of the angle, so 9 squared. And then it equals, it doesn't matter where the other two go, so 4 squared plus 6 squared minus 2 times 4 times 6. And then cosine of the angle we're looking for, which is angle B. All right, so we've got a little bit of simplifying to do before we can undo taking the cosine of that angle, so we're going to have to take the inverse cosine. So let's just do some of the squaring. That's 81, 16, 36. 2 times 4 is 8, times 6 is 48. Cosine of B. I'm going to go ahead and add the 16 and the 36. 52. Minus 48, cosine of B. Again, really tempting to say 52 minus 48 is 4. But that 48 is being multiplied to cosine of B, so we can't combine those. Instead, I'm going to subtract 52 from 81, and that would be 29 equals -48 cosine of B. And now to get cosine of B by itself, I need to divide by -48. So 29 divided by -48. And now to get B by itself, we need to take the inverse cosine of -29/48. And that ends up being inverse cosine -29 divided by 48. 127 point, rounding degrees, or angles to the nearest degree, So 127 degrees. Okay, and that's what I mean about getting that obtuse angle. We're only going to get the obtuse angle from the inverse cosine, not from inverse sine. Okay, so if you forget about this, you can get lucky and you might get this angle to be 127, but it's not going to always be the case. Okay, so again, commit to knowing this. Find that largest angle first. So now that we have an angle and a side length opposite, we can use law of sines to find any of the other remaining angles, and then use the fact that they all add up to 180 to find the last angle. So let's find C next. So I'm going to take 9 divided by sine of 127 equals 4 over sine of C. And so I'm going to work to get sine of C by itself. I'm going to not show all my work here. So I'd cross multiply and then divide by 9. So that's 4 sine of 127 divided by 9. And so C equals the inverse sine of that value. So inverse sine of 4 sine of 127 divided by 9 is 21 degrees. And then finding the last angle, we just got to use the fact that they all add up to 180. So 127 plus 21, 148. 180 minus that is 32 degrees. Again, the only thing that is going to work out weird on Math Excel is the rounding. Be patient with it. And if you get stuck on them today, I'm happy to come help you. Okay, any questions here? I'm going to have you all work through one application problem, and then that'll be it for these notes. And we're going to actually do this application in 2 parts. Part 1, this is a bearings problem, so I want you to draw the diagram representing the 2 airplanes leaving the airport. We will all stop and check to make sure our diagram is correct before you then go ahead and use the law of cosines to answer the problem. Okay, so go ahead and read this. I'll zoom in a little bit. Draw the diagram to start. We'll go over that diagram, make sure everyone's on the same page there, and then solve it after that. So here's the diagram, and I'll explain the bearings. So I know some of you that are just new to this class may not have gotten the bearings previously. So when this is north 66 degrees west, when we're drawing a bearing, you're basically still working in an XY coordinate plane. It's just that now we add the directional component to it. So north, south, east, and west. The origin is basically where all these things start from. In this case, that's the airport. And so when it says that plane, one of the planes flies on a bearing of north 66 degrees west, the north part means north of where they started, west of where they started, and it's the angle that you kind of have to think about where that gets drawn into. The angle will always get drawn in from the north-south line and then directly to the path of the object. Okay, so this line is that path of the plane, and so the angle is 66 degrees off that initial north-south line. Same thing with the second plane, it being south and 26 degrees west, it's 26 degrees off that exact north-south line. Okay, so that's the bearings part, and by drawing this diagram, we know that we're going to find this side length x, but we need something, actually we need a couple things to be able to figure that out. First thing is, airplane 1, if it travels 325 miles per hour, how far will it have gone in 2 hours? 650, okay, good. Just multiply it by 2, which means that airplane 2 has gone 600 miles. So right now I know 2 side lengths. It'd be nice if we can get an angle. How can I find this angle, Julio?
You add the two 66 degrees and 26 degrees and then subtract that from 180.
Excellent. Yep, that's it. Okay, this whole angle right here is 180 degrees. Okay, going from basically just a straight line. And so for us to find this missing part, we just got to use the fact that all three of those add up to 180. So 180 minus 66 plus 26 is 88 degrees. And now you can go ahead and do the law of cosines. And I'm going to let you all do that on your own. Round to the nearest mile. Check our work. And then get you all going on the assignment for today.
Why wouldn't we just use the law of sines?
You can't.
You can't.
Oh, I first.
B squared equals 650 squared plus 6 squared minus.
But I got it.
All right. We'll just check real quick, make sure you got the right answer. All the work's the same, but you should end with 869 miles. The numbers are big, so if you forget a zero, which I did the first time I worked through this problem, then you get different values. So just be careful. There's attention to detail. Again, if you just want to plug it all into the calculator right from the start, that is okay with me. But make sure that you're still writing the equations down. That way you're showing some work. If it doesn't work out, you can still get some partial credit. Okay, I'm not going to go through each step. If you're confused by something, please ask. The rest of the period is your time to complete the Math Excel assignment. It is due on Monday, since we do not have school on Monday. It's due Monday night at midnight. No problem with y'all listening to music today either.